was a beautiful number 1.
Here.
I know. Okay, so we're factoring that denominator. What does it break up into? X minus 2, x plus 2. Okay, so that was step number 1. We're focusing on this so that we can find our vertical asymptotes, which are x equals 2 and x equals negative 2. Alright, so hopefully, if you haven't already done this in your notes, that you are doing this with me. Because I know some of you didn't do any of this last night. Okay, so step 2, horizontal asymptotes. Largest power of x in the top, largest power of x in the bottom. What am I going to do with that fraction? Take the limit as x goes to infinity. So what happens to that fraction is x gets bigger and bigger and bigger and bigger and bigger. I mean, I know and you know that every time you plug a number in there, you're getting a negative result. But what's happening to those fractions? Their absolute value is getting smaller. They're actually getting bigger, but you know, I know that's beside the point. But they're getting bigger and bigger and bigger. What are they getting close to? 0 is correct. They're just getting close to from the bottom side there. So that would be 0, which we know that means you just found your horizontal asymptote. Are they always going to be y equals 0? No, folks, they're not. Now, well, just think about really, really big numbers, like, you know, plugging in -1 over a million. Not only -1 over a million, but -1 over a million squared. So the bottom is just massive. The top is -1, so the fraction is an extremely small negative number. Well, if that denominator keeps getting bigger, all you're doing is getting closer and closer to the y value 0. Now, I am for a moment going to clear the screen and show you something, and then we'll come back to this, so don't panic. I'll get it all back. I know. Alright, so I need... That ain't it. Come on. Show me the camera. Here are a couple different rational functions that have 2 asymptotes. Okay? I need you to just look at these pictures for a second. If you're plugging in a number over here and it gives you a positive, it's easy to tell what that branch is going to do. If it was down here, I know that that would be reversed. So what my point is, what I'm trying to get at is, on the outside of those 2 vertical asymptotes, it is not really that hard to plug in one number and you know whether the branch is going to be above or below that horizontal asymptote. That's not too hard. The question I have for you is, what's going on in the middle? Because sometimes you get these kind of things that look like cubic functions, fake cubic functions. Why is it a fake cubic function? Because cubic functions don't have what? There isn't a polynomial function out there that has asymptotes, right? So those vertical asymptotes are stopping it, so it's not really like a cubic function, nor is this one in the middle like a parabola, so I guess you could call it a fake parabola. It has those vertical asymptotes, but it's doing that type of shape. So is it doing something like this in the middle or something like this in the middle? That's why you have to plug in more than one point in the middle. So when we go back to this question, yeah, I'm going to make my chart just like we've talked about, right? Kind of step 3 in the whole process, making my chart. Give me a value on the far left that you want to use. Far left. Past the asymptote. -3 works. But I'm going to suggest to you that we also need -1, 0, and 1. And then on the outside, I'm going to use 3. So these right here in the middle are helping me understand the shape of the graph in the middle. It's not going to be hard to tell what's going on the outside, but it's in the middle that I really need to figure it out. So, your team of experts shall plug in. You guys plug in 0, check the M, 0 part. You plug in 1, but you check with those two, right? Plug in 1, check with those two. You 4 back here, plug in +3. +3, yes.
So when this appears on the text, like not using that, like,
yep. No, there's no reason to use a calculator. I mean, so far, what are you talking about? This last step? Is that the only part of this? Well, I could see like a little I-step calculator, if that down here at the very last part, if that would help you. But I'm not going to make them so terribly unusual that you couldn't figure them out. So check with your neighbor on the numbers, on the people that are around you, to make sure you have the right number. So you guys know that you're supposed to plug in 3. So go up to your function, plug in 3, and tell me what you do. See, that wasn't hard. You didn't calculate everything. All right, when you plugged in a -3, what did you get? -1/5. That's true. Okay, let's see if we can plot that. And we'll get our numbers first. How about -1 out there? -1 is +1/3. How about 0? +1/4. How about 1? +1/3. How about the 3s? -1/5. Sorry, ran out of room. Okay, let's see if we can... folks, for ease of visibility, since older people are more blind, I'm going to expand the y-axis scale for our eyes. -3 and -1/5, so, we're talking somewhere in the neighborhood right there. Does that make sense to you that now this branch is somewhere like this? I guess I forgot to put my horizontal asymptote on there. Shame on me. Okay. +3 also gave me -1/5. So, doing something like this over here. And then in the middle here, -1 gave me 1/3. 0 gave me 1/4. And 1 gave me 1/3. Do you think we're doing that little cubic thing in the middle, or the fake parabola? Which would you prefer? The fake parabola. Whoa, I missed. That's tragic. Understanding the picture. What's your domain? -∞ to -2 union Negative 2 to 2, union 2 to infinity. Three parts to that domain, 2 separations in the middle. Yes, I know that there would be 6 total limits that you'd have to write, right? 3 for each one. Okay, I'm just trying to speed up the process since we talked about and reviewed that idea of limits yesterday. Yes.
So I get that. How do you know what's inside of the
Well, you need to know you need to have a basic idea of what the parts are going to do on the inside and outside. The outsides are the easy ones. You really only need one number to guide you into knowing where the branch is. It's in the middle where you're going to have to typically. So like on the first example we did, we only had one vertical asymptote, so I only needed to pick one value on either side. I didn't have that middle thing to worry about. So when you have a middle thing to worry about, then you got to plug in a few more numbers. Okay, what's question 21? Because somebody was talking to me second period, and I just want to look at that. What's question 21? 2x plus 1 over x squared, is it minus x? Okay. Is the denominator factored, yes or no? No, it's not factored. Okay, so help me factor that. X times x minus 1. Alright, so what are my vertical asymptotes? X equals 1. Yeah, that's definitely one of them. And x equals 0. Make sure you write it down as a vertical line. Don't just write down 1 and 0. Okay, that's how you lose credit. I don't want that to happen to you. Okay, so we've got a vertical asymptote at x equals 0 and at x equals 1. Who the heck was this dork that made it like this? Don't I have to eventually plug in numbers to this? If this is 0 and this is 1, what kind of numbers am I going to have to plug into the middle? Fractions. What kind of evil people are these? What kind of fractions would you choose? 1/2, great choice. 2/3, come on. You could choose 2/3 and 1/3 if you really wanted to torture yourself. But what about something like this? How about 1/4? Or and 3/4? Now, if you really like the 1/3, 2/3 idea, it's okay. You can do that too. I'm not going to throw a test question at you which requires you to throw in fractions like that, okay? I'll be nice enough to make them integers far enough apart that you're not screaming. Okay? What about your horizontal asymptote? I'm just curious. What are you going to do with this thing? Does 2x over x squared reduce to anything? Does 2x over x squared reduce to anything? 2 over x, right? Okay. What's that? Okay, talk to your neighbors. You got about 20 seconds to figure out as x gets bigger and bigger and bigger and bigger and bigger, what's going on with that fraction? 2 divided by million, billion, divided by trillions. it's getting closer and closer and closer to 0. Hey, got another question for you. What if this number up here was 1,000? What if you took 1,000 and divided by x? What? Would it still be going to 0? Remember, how big is x getting? Really, really big. I don't care what number you put on the top. Infinity will always swallow it. Alright, so it's got it taken care of. Alright? There ain't no getting away from that when it's infinity in the denominator there. Is infinity divided by infinity 1? Okay. Alright, you can argue that one if you want to. Okay, so that's your y, your horizontal asymptote to this graph. I won't go through the rest of this because you know how to make your chart and go on from there. I just thought I would see what you would do if they were nasty numbers. Would you understand? Okay, moving back to our notes. And I would. Well, you would make your chart, right? You make your chart, and I think you would probably, just like we talked about, you would pick numbers on the left side. You could even pick -1, and on the far right side, you could pick like +2. But then for the middle, like we said, we would have to pick 1/4, 1/2, and 3/4, which kind of get ugly when you have to go through those with fractions. So I wouldn't do that to you on a test. I'll just let you plug those in. And remember, the solutions are all online, right? If you go to Files, you can open up to Chapter 2, and you can look at all the answers. When I was growing up, we just had the odds. You guys have everything. Just like you.
What do you have?
You have the odds.
The odds?
Yes, the odds. You have everything. You have the odds. You have the evens. What in the world did I say that was so wrong? Seriously, how can you misconstrue that? Oh my goodness. What is wrong with these people? Alright, let me get my... not olives. Is everything okay up there? Not like the uncooked variety?
Oh, okay, so it's like plastic rice. Like plastic. You know, rice all rice.
Plastic rice? Do you like have a bowl of plastic rice at your house for decorations? Okay, so we ended on this example. One of the things that they said in this particular example was that you needed to be able to find the transformation. And yes, I can look at that denominator and I could say, oh, it's been moved to the right 2 units. And yeah, we found the horizontal asymptote, so we know that it's been moved up 3 units. But what about the stretches and the shrinks? Okay, stay with me. Stay with me. Stop Googling uncooked rice. You know that's what they're doing. Seriously. In order to figure out the transformation, we need to divide 3x minus 7 by x minus 2. What would you prefer, long or synthetic? I'm going to say most of you would say synthetic, even though some of you really need to practice your long division. Yeah, yes, yes, yes. So if 2, x minus 2 is the factor on the bottom, what are we dividing by? 2. So what are the coefficients of the things across the top row? 3 -7. Yes, folks, this is going to be a pretty quick synthetic division. Why don't you do it? And then after you do it, I want you to interpret what you have.
A remainder.
Yeah, there'll be a remainder. I got you there, but nobody said it was a factor. Okay, good. Now interpret what you have. You are correct. You've done that synthetic division correctly. I just need you to interpret what you see. Okay, so first of all, if you don't know what to do with your remainder, why don't you write the remainder first? Write the remainder first. Maybe that will help you to identify what's going on. Yes? Okay, so over here, I'm on letter B. The function 3x minus 7 divided by x minus 2. So we're doing synthetic division to actually do that division. So 2 is the 0 that you get from the denominator, and the top only has the two coefficients, 3 and -7. Does that make sense? Because the first one was already in the or close to the fireproof form, so we didn't have to do this. But that's a good question. So hopefully you carried down the 3 and then you multiplied and you added. Wow, that was quick. You did that, correct? Now, what do you have? That's my question. What is this thing over here? So write it. How do I write it? -1 over x minus 2, right? And that gets added to what? 3, because that's the constant. Look what you have. You have a parabola. Sorry, not a parabola. A hyperbola. Now, put it in fireproof form. There are 2 steps to do this. 2 things to do that you need to move to the y side. That's a great idea. Do it. Get the vertical changes over there. There's 2 things to do. If you only know one of them, then at least do the one thing that you know. What do you think we should do first? Okay, move the 3.
So fire's all this orange.
It's almost. There are 2 things that need to happen here. The first one is subtraction. Yes. Oops. Too much. So we pushed that to the other side. I heard several of you tell me to subtract. And that's not quite in fireproof form. What do I need to do? Divide by -1. So my final form is going to look like this. No, dividing by -1, it's only going to change. Okay, so but if you're dividing by -1, the only thing you're going to do is that on that side. You're not. If you change the top and the bottom, you've actually multiplied by the number 1. Because what you're doing is you can only change either the top or the bottom, but not both. Well, the goal is, remember, the generic fireproof form for a hyperbola what do you notice up here? You notice a +1.
Good afternoon, Spartans.
That's the generic.
Afternoon announcement for all of you taking the Personal Financial Responsibility Test, PFR test today. That's in the cafeteria right after school. Please get there promptly. There are probably 245 of you-ish who will be taking that test. Those of you who are freshmen and sophomores taking the PFR test, Personal
things to do. Come on.
Have a good day, Spartan.
Okay, now we will. Now, can you tell me what's going on? You need to describe the three things that are going on here. Okay, somebody is going with the reflection. Yeah, reflection across what? That's across the x-axis because you're changing the y value. Yes. So, what other two things are happening? We got a right 2, and we've got 3 up. You would not have known that unless you did the division. Yeah, we could get the 2 shifts by doing what we did before. But you wouldn't know what's going on in terms of scale changes and shrinks and reflections unless you actually work it out. Okay? So keep going on homework questions, and we will get to more notes mañana.